Hey, Chem 345, I wanted to pop in, give you guys a quick little update where we're at. We are finishing week 2. We've got an exam on Monday. Real quick, your quiz is uploaded. Your grades are listed in the assignments on your specific PDF. I am still struggling with uploading this CSV document. I'm not sure what's going on. I'll show you real quick how you can see it. Real quick, the average was 15.2 out of 25. This quiz was difficult on purpose because you could use your colleagues. So I push you and encourage you on the next quiz to keep using your colleagues for questions like this. The quiz key is also listed here, and here I have specifics. Reach out to your TAs if you have questions about how it was graded. They graded it based on the key that I made. Let's look real quick at your assignments. You've got a quiz, you have an exam on Monday. It is at 11:45 on Monday. This is Central Standard Time. The quiz, there were some issues. Some students didn't realize it was on Monday. Look, the exam is on Monday, 11:45. It ends at 1:30. Do not try to upload your exam at 1:30. I'm giving you guys an additional 30 minutes minimum to upload your exam. This is timed. I want you guys to try to upload it well before the 1:30. So when it hits 1:20, you should already be uploading. You can still check your work and re-upload a new PDF if that's the case. So I would suggest at 1 o'clock, go ahead and upload your work, and then go from there. You can check your work over, and then you can. Okay, let's jump over. There's a couple things I want to talk about. What can you use on your exam? You can use your book. You can use Google. You can use your notes. You can use anything that's on the Canvas page. You can use all of it. You really do need this one. You need your appendix. You will use that quite a bit. What can you not use? You cannot use your classmates. You cannot post the exam online and try to get help. You cannot use tutors. And you cannot use me or your TAs. This will only hurt you if you try to use your classmates. There are ways that I can tell on exams when people are working together. So this will only hurt you in the future. There's no point to cheat. I do, however, want you to use the resources that you have available and around you. I can't control what you're Googling, and I highly encourage you to do so. You're going to use Google in the rest of your life. Let's talk about the concepts that are on the quiz. I saw some questions about, what about Chem 343 material? What's on the exam? We're going to talk about that real quick. What about if you have an Ortho Para director? How do you know if it's Ortho or Para? It looked like in the lecture videos he needed a reaction to be run in order to explain the selectivity. I'm going to discuss exactly what will be tested and what your knowledge should be. Nothing in this video is going to affect whether or not you do well on the exam. I'm just highlighting some things that should have come through in some of the problem sets and then the practice exams that are posted. So if you didn't get a chance to watch this video, you are not at a what would you call it? Rhodey, what would you call that? My cat knows nothing. She's not helpful. At a disadvantage. Really? That was the word I'm trying to find. All right, what else am I going to talk about real quick? Use of, let's say, I'm just going to say equivalence. Use of equivalence in reagents. So for example, when you were looking at Friedel-Crafts chemistry, so let's say something like, you could get away with less than one equivalent. This is saying one equivalent. However, you might have seen an example where maybe if you had a carbonyl on your compound and you were trying to do the same type of chemistry, you would need to use more than one equivalent. And why is that? Let's just go briefly over that. Let's say 1.2 equivalents. The reason is because this carbonyl can bind to this Lewis acid. This is going to use up some of your AlCl3, and you need this for the reaction. So in a case like this, when you have something that can bind to AlCl3, you would need to use more than one equivalent. So just keep a note on that. One other thing about equivalence is if you have, let's say you have something like this. In the lecture videos, he talked about overbromination. One of the ways I'm just going to make it really clear, and again, this is on your practice exams, is I will just write one equivalent if I only want you to add one bromine. We've kind of talked now about equivalents. Let's jump over to Ortho Para. How do you know if it's Ortho Para, and how do you know what the major product is? We've talked about in class how if it can direct both ortho and para, you need to look at other things such as sterics, right? In this case, the main thing I want you to remember is that typically you get a para addition. So in this case, I've got one equivalent of bromine. That's actually kind of hard to control in a reaction, but let's just say I can exactly add one equivalent. You're going to get the para product as the major. And typically for exams, unless I say something else, I always want you to draw the major product, okay? We're just going to utilize this moving forward. Again, this is on your practice exams as well. Now, if in the case, on the lecture notes, you would have seen a special case of toluene and the nitration of toluene. And he talks about how actually the ortho product is favored. If you kind of think about this kind of, when you look at this, you've got one para position and then you have two ortho positions, right? And so when you think about this, statistically, it makes sense that you would also get quite a bit of ortho. You have two positions. And what he's talking about here is that this CH3, this CH3 group is so small, there's not much of a steric interaction. So it's not really going to affect, sterics isn't going to affect this reaction that much. I'm not going to ask you to know that. The only way I would ask you to know that or would be to describe it is if I gave you a reaction and I explained what happened for the product ratio, okay? This, of course, would be an acceptable answer, but for any ortho para director, just remember that the para, I will always accept the para being the major. And if there's something I need you to describe why a certain reaction went a certain way, I would expect for you to be able to explain either with a dipole interaction or sterics in your explanation as to why something didn't go para. Typically, again, we see para because there is typically some steric interaction when you add to the ortho position. Does this make sense? I hope so. So again, ortho para directors, I'm typically going to ask you to always remember the para is favored. In a case where you do end up getting an ortho, I will use it in a description where I give you reaction conditions and the ratios that you receive in the reactions. It will be more of a discussion. But for the majority of the cases, I always want you to draw the para position adding. Unless, of course, the para position is blocked, okay? Let's go over now Chem 343 material. What is it that you need to know? We are talking about aromatic chemistry. Everything in chapter 16 is fair game. So when you talk about Chem 343, what is relevant is really what could be asked, okay? I could ask something about acid-base chemistry, okay? For example, in your discussion problems, you've talked about some things being protonated, and that changed something from being an ortho para to a meta director. In the lecture, he discussed this amine and what happened when it was protonated. This is ortho para. Now this is electron withdrawing, so this would direct in a meta fashion. Carbocations from Chem 343. When you were doing SN1 or E1 type reactions, this is absolutely relevant. We know in our work with Friedel-Crafts chemistry, if I react with this alkyl chloride in the presence of aluminum chloride, I'm going to see a rearrangement. You should be able to use your knowledge from Chem 343 and the stability of carbocations to draw this reaction mechanism and to explain why you get reactivity on a secondary carbon and not the one on the end. So here we're getting it at the secondary carbon here instead of this carbon at the end. You should be able to use your knowledge about carbocations. Another thing that can happen, you see now that this benzene ring can react with carbocations. You've seen that before in that mechanism. So for example, if you were to have, whoops, can I delete this? Great. So keep in mind that from Chem 343, you could have something like an alkene in the presence of an acid. You know that this can make a carbocation. This is an electrophile and can be used in EAS reactions. Notice how this Chem 343 topic is now used in aromaticity, right? Carbocation formation, carbocation stability. A secondary is more stable than if it were on a primary carbon, things like that. Acid-base, carbocations, what else? Chem 343. I'm not going to ask you something like, I'm not going to ask you something about a reaction, like a very specific reaction. I think you guys learn like ozonolysis. Like, I'm not going to ask you something like that. I'm only asking you things that are tied in with this aromatic chemistry, and in particular with electrophilic aromatic substitution. Let's dive into one more example here. Wait, did I get that Chem 343, Ortho Para, what to know? Yes. Now I'm kind of jumping around just a little bit. For the Ortho Para, just so you know, one other little thing I've seen that's started to come up. I just talked about how the para position would be something that is favored. Let's just see this. So let's say I've got this reaction and I want to add a bromine. How am I going to communicate to you? We're just going to add one. I'm just going to write one equivalent. That will make it easiest for everyone. How do I know where this reaction is going to occur? Right now, I've already talked about the things that would be relevant to the exam as far as Chem 343, a couple of the topics, how I'm making it clear, and then what you can and cannot use on your exam. Now I'm kind of getting into some specifics about some questions I'm seeing on Piazza. When I look at this reaction, let's just talk briefly about how do you start the reaction. You know that this is an electrophilic aromatic substitution reaction. You are going to generate an electrophile with these two reagents. You should be able to draw the mechanism for this. What you want to do is you want to look at what is bound to the aromatic ring. I have an OCH3 group and I have a nitro group. Let's designate each either as an Ortho Para director or as a meta director. I highly suggest having, I think it's page 812 in your book. I know it's table 16.2 open as you take your exam in case you have some issues remembering it. I prefer you don't memorize things. I prefer that you be able to explain why certain things are the way that they are. Anyway. We know an OCH3 group is Ortho Para directing. You should be able to draw the resonance to show that oxygen is able to donate its electrons into the ring. An NO2 group is a meta director. You should be able to do the same here to show that the NO2 group is withdrawing electron density from the ring. How do I know where the reaction will take place? Well, first off, based on this, I know I'm going to add one bromine. I could draw out the mechanism and form the electrophile. On an exam, for every question, you might not have time to draw the mechanism. In fact, I highly suggest you don't. You should be able to look at a reaction and quickly know what transformation is happening and be able to draw the product without the mechanism, as well as be able to draw it, but don't do that every time. It'll take you way too long. You don't have time for that. Ortho Para director, we know that activators are the thing that control reactivity with EAS. Why do we know that? We know that because this is our nucleophile. Nucleophiles are going to attack electrophiles, right? So the more electron rich this nucleophile is, or the position in which it's more electron rich is going to affect where it attacks, okay? Where that bromine is now added to the aromatic ring. So let's look at this. So I'm going to use blue for my Ortho Para, and then I'm going to use green for my meta. My Ortho Para director is going to push this chemistry, right? this would mean that these two positions are open. Well, this one's open as well, right? No, this is a para position. I just talked about how para is favored, but in this case, you can't react there. There's already a nitro group there. That means the only position open would be on an ortho position. If you looked at the meta director, you'd see it actually maps on as well. But again, this is not determining the reactivity. I kind of like to think about Ortho Para as directors, and I like to think about these, they call them meta directors. I like to call them meta allowing. It allows the benzene ring to react in a meta position, but it's not necessarily directing it. An Ortho Para director is pushing electron density into those carbon positions. So in this case, again, you should be able to draw the mechanism, but I want you to get really good at looking at the conditions, deciding what groups you have on, and then adding the appropriate electrophile, or whatever the conditions were telling you, to the position.